You have 5 minutes.
All right. Well, I'll tell you, the first time I did a lightning talk for PyTexas was around 2007, 2008, one of the early ones. And I spoke for 45 minutes. So I'll try to do a little better today. Okay. All right. So I'm one of the authors of Python in a Nutshell. I've joined at the 4th edition with Alex, Anna, and Steve. And this is me in the corner there. And I've got my Twitter handle, and this hashtag is what that we collectively use when we will tweet or post on Mastodon. So you can follow along with news for the book with those handles. Watch for some QR codes. I've got QR codes on a number of these slides as I point to websites and so forth. So be ready for those when you're interested. So I'll dive right into some of the things that we picked up while we were working on the book. The first one, there's a chapter in the book very early on is how to build Python from source, or how to install Python, and one part of that is building from source. In doing the analysis or the survey for this, I found this great website for Linux systems, buildpythonfromsource.com. And you check various switches on which Python version you want, which Linux distro you're building for, and then it will emit all the bash commands to download, build, and install that Python. And there's the QR code for that. I'll leave that up for just 10 seconds because I need to move forward. Okay, the next one. When we were doing the syntax, I discovered that middle dot is a valid identifier character. So this is kind of a crazy thing, but and there's no key on the keyboard, but for you Mac folks, Shift Option 9. Windows people, it's Alt 0183, and you can write variables with a dot in the middle. That is not the period for an attribute. That is a middle dot. We also did some analysis on Unicode characters, normalization of Unicode down to ASCII. And here we have just some pretty standard kind of hello world, a little verbose maybe. This is the exact same program using Unicode characters because, and in fact, this will run identically with that one on the side. Because Python will convert identifier Unicode characters, will normalize them back to normal ASCII. So you'll see that it's only the identifiers, none of the keywords. And but there's a lot of identifiers that are built in, print, all the exceptions and so forth. So this is a sort of a ransom note kind of approach. I have a website that will actually do this. You can play with this, play tricks on your friends. And this is the QR code to get to that. We'll pull up a little window to paste in some Python code. It'll generate that code on the right. Okay, you can count higher with ints than you can with floats. Here's a little loop that displays values around 2 to the 53rd. And you'll see that floats, they lose integer precision at 2 to the 53rd. Sometimes the values go higher, sometimes lower. Integers, you can count as high as 2 to the 63rd. It's about a 2 followed by a billion zeros. That's a theoretical limit. I tried to reach something close to that, and I blew up my memory, so I've got to hurry. So stir function surprises. This is actually not a new feature, but who can tell me what this is going to print out? L.com. I wanted to strip off HTTPS, but that is not the string to strip off. Those are the characters to strip off, and that matches all of those. In 3.9, we have remove prefix and remove suffix, and that does the intended stripping of that substring. We found in general discussion and surveying our network, there's actually some latent bugs in our code bases. Search for lstrip and rstrip that take no arguments, good for stripping white space. But if they're taking a quoted string, you may have actually slipped into this bug, and watch for that. I'm just gonna do this real quick. The sort method in Python was presented before the Supreme Court as part of the Oracle versus Google source code. And there's the QR code where you can look that up. And lastly, the appendix for the book has all of the code changes from 3.7 through 3.11. And there's this website where you can actually do keyword search for changes by version. Thank you very much.
Awesome. Thank you, Paul. All right. I've got to move to something louder next time because that did not work. But, okay. Next up is from the volunteer team zone, Josh Schneider.
I'll be mercifully quick. Two things first. Number one, if you were here last year and saw my talk last year, this will all seem really familiar. And number two, I want to confirm, Chris, you and I did not talk before I came up here and did this, because it's going to sound real familiar too. But I talked about this. This was like one of my first slides in my talk last year, but this bears repeating. I think these words will be carved in my tombstone, probably. But this is Josh's 3. Make that 4 rules for user experience design. That's fine. I don't need tiny cue cards. No Dr. Horrible fans here? Okay. I will start with rule number 1 while I am trying to get everything duplicated here. Rule number 1 is, and repeat it with me if you'd like to, make it obvious. Why make it obvious? Well, because if it's obvious, you don't have to tell people how to use it. It'll be obvious. And this is just not behaving, so that's fine. I can go without slides because I can animate myself. Rule number 2. If you can't make it obvious, make it familiar, right? If you make it familiar, you can borrow what the user knows about another topic to learn your thing. So if you're implementing something that, say, parses path, fitting the same interface as, say, pathlib, makes it easier to translate that to other users that are using your library. So you can borrow what somebody knows about one thing to use it for another one. Rule number 3, if you can't make it obvious or familiar, for the love of all that is good, make it well documented. Make sure there are copious notes on how to use it, all of the edge cases and corner cases you can think of. You never know when that stuff's going to come in handy. And then those were my 3 rules that I've always had. Rule number 4 has snuck in there from all of the conversations I've had. And rule number 4 is very simple. Start at rule number 1, not rule number 3. Well documented is not good enough. If you can make it obvious or familiar, those are better than well documented. If somebody has to look for your documentation to use your thing, you've already lost a percentage of your audience before you've even started. Go for obvious. And that's it. All yours, sir. Thank you. And Mr. Brad.
Didn't even get to use my new alarm. How sad. Is it working for you?
Yeah.
The technology ghosts are going to play nice with us this time. All right. Al Sweigart again.
All right. Has this ever happened to you where you're leading a 3-hour introduction to Python or something like that, and you want all your students to install some third-party package from PyPI? This is going to be a nightmare, and you spend the next 45 minutes of your 3-hour workshop just getting the package installed because some of the students have Windows, some have Mac OS, somebody has FreeBSD installed on their laptop for some reason. And not only that, but they all have different versions of Python installed. And not only that, you have to explain how to use the terminal or the command prompt as it's called on Windows, or maybe they have PowerShell installed, and you have to explain what environment variables are, and you have to tell them, oh, you need to modify your bash RC file or your Z shell RC file, depending on the version of Mac OS that they have. And this is all such a pain. And yes, they do need to eventually learn how to do this so that they can run pip and install Python packages, but you just want it to work right now. Here's the solution. You can run pip from the interactive shell. Just import pip, do pip.main, and then you have to pass it a list of the arguments. In this case, install Django or install whatever you want. This works on versions Python 3.5 and up. It even works on 2.7 for some reason if you need that. It works on Windows, it works on Mac, it works on Linux, it probably works on FreeBSD. I haven't checked. It works even if they have multiple versions of Python installed, because whatever the interactive shell that they're using, that's the one that's going to install to. If you've ever had that problem where like for some reason the environment variable was set up where like pip was for a different version of Python than the Python thing was, just so many headaches. You can run it from the interactive shell. This is not a best practice. If you want your Python application to run pip for some reason, you would not want it to just directly run this. And I think actually Python gives you some warning, but hey, this is how you can do that if you just need to get something installed so you can continue on with your workshop or your class or your blog post tutorial or your video or whatever. Pip.main and then pass it a list. Okay, thank you. That's all.
All right. We are moving right along. I love this. All right. Next up would be, is it Shreya Batra? Is that correct? Okay. You need an adapter? Sweet. I think we can do that. Let's see if that works for you. There you go. Don't worry about it. Just toss it down here. And then you might need to do... Oh. We're getting there. Yes, awesome. All right, all yours.
Thank you. Hi everyone, I'm Shreya. I'm a PM on Azure Functions, and I wanted to come and talk to you all about kind of what we're doing for Python these days and our investment in the Python space. So before I start, I just wanted to ask, have any of you used any serverless technologies in the past? Oh, thank you. Serverless technologies. Okay, awesome. So quite a few of you. And could you keep your hand up if you've used Azure Functions specifically? Okay, some people. Okay, awesome. And then Azure Functions in Python. Okay, awesome. We have one person. Thank you. So yeah, before I start, I do want to talk a little bit about Azure Functions, since I know a lot of you may not be familiar with it. And then I'll just kind of go into what we're doing for the Python space. Awesome. So what is Azure Functions? Azure Functions is the serverless compute from Azure. And the idea is that you just focus on your code, you just write the business logic, and we take care of the rest for you. And I'll just go over like quickly some examples of commonly used times when you might use Azure Functions. So here we have a database that we want to clean regularly on a timer. So we can actually configure an Azure function that will go ahead and run some business logic to perhaps deduplicate data and clean that database for you every 15 minutes. So this is probably a really common use case for our customers. A second one is real-time stream processing. So here we start with an app that's producing some data, and we want to end that with like the data in a dashboard where we can track different metrics on that app. So as you can see, there may be an issue where we need to process data between different data sources, and Azure Functions would be a great tool to be able to do that. So in these two examples, I've kind of just had this little functions logo to represent that code, that business logic that you'd be writing. And I just want to go into a little bit of detail of like what that would be actually. So we have this trigger that would run the code that would invoke the function that you have. So the trigger could be something like an HTTP request. It could be off of a database. It could be on a schedule or a timer. And then we have these optional aspects of an input and output binding if you need more data to process the code, and also based on where you'd want to put the code afterwards. And also, we are completely open source. So if you would like, please do check out the Azure Functions repository. You're welcome to contribute or ask questions and take a deeper dive into the repository if you are interested. And then now I just want to kind of talk about our new release for Python. So one of the main initiatives that we're focusing on in Functions for Python is being able to provide an experience that's more native to Python developers. So whether you're just getting started or you're an experienced Python developer, we don't want the experience of using functions to be much different than what it is like to code natively in Python. So we've released this new programming model, which is still in preview. And some of the new offerings are that we see decorators to represent triggers and bindings. And we also have added like a lot more documentation. So if you are interested in functions at all, I know a lot of you haven't used functions before, please do give it a try, like especially this programming model. And if you do want to give it a try and you have any feedback or any questions, please feel free to reach out to me. Yeah, thank you so much for listening.
Next up, Josh Cannon.
Yay. I have 23 slides, 5 minutes. I've not rehearsed this. If you're using your calculator, that's 13 seconds a slide. I talk fast. And there's adrenaline involved. Oh no, I want to hear the buzzer. Can y'all hear me? I talk loud enough, so hopefully. Oh, come on. Oh, that's. Okay, it's down there. Oh Lord. Let's try that. I'm getting like picture in picture. A little weird.
All right, are you ready?
Let's do it.
Go.
2 snakes in a trench coat descriptors. Okay, so a lot of you might be familiar with getAttr, which is how do you get me? It's half of a handshake. So if I have this order instance thing and I ask for a brisket taco, which I usually do, if it didn't exist, you'll go for getAttr. It's great. How do you get me? There's also getAttribute. Nobody uses it. But doesn't the brisket taco get a say? I don't know, like the Chick-fil-A cow or something? So let's take a real-world use case that I've refactored, because refactoring, yay. And the first thing is you have this my menu thing, and it inherits from menu. You have this class method called register options, and here's where you do like command line stuff, and here's your brisket taco, and you say it's a type string, because I don't know what type of brisket taco is. Great. And how you access it, again, this is some code that already exists. We're going to make our order instance of my menu. And ooh, yeah. So first I go through this items thing, and you can't type it because it's dynamic. And then I have to cast it. I don't like casts. So then, I really just wanted to do this. Give me the brisket taco from my order. And so, okay, you write a property. Now we've isolated the cast. The user doesn't cast. The property does. And that looks pretty good, right? Somebody once said, if you weren't paying attention in a meeting and they ask you a question, just go, but does it scale? No, it only fits on a slide because it made it smaller. Here's brisket taco and bean and cheese taco and mac and cheese and baked beans, and apparently I'm talking before lunch and dinner and making you very hungry. So won't somebody think of the brisket taco? Probably Rudy of Rudy's Tacos. I don't know. Wouldn't it be cool if I could write this? And you can, because I'm on a stage talking about descriptors. So descriptors come in 3 little magic methods. The first is dunderGet. I won't tell you the second. It's dunderSet. I'm not even going to show it. And it looks like this. You take the instance, which on this slide was the menu item instance that is brisket taco. It's that class attribute. The second thing is either going to be the instance being operated on, in this case my order, or if it's a class attribute, you're accessing it like that, then it's none, and then you get the class always unconditionally. And this is, for some reason, the default's to none. That's what Python docs say. Don't ask me why. So this is great. This is the other half of that handshake of, hey, how do you get my attributes? Certain things get to say, well, how do you get me? So great. If object isn't none, if there's an order I'm operating on, I'm going to use the getAttr thing. Oh, wait, I don't have a name. Because these were one instance for all of them. Somebody thought of this. DunderSet name, where we set our name. And this gets called right here at the end. When you're done defining your class, it'll call set name for all of them. So let's do the other half. Oh, sorry, nope, we filled in the name. Yay, we have a name now. You can access me. Whee! Now we need to register the options. This part's mostly just plumbing. If the object is known, you called it on the class and not the instance, and then maybe the menu superclass gets to go ahead and access all of the attributes of that subclass, and if it's this magic registration object, yeah, it's plumbing. The cool thing is that I can sprinkle in a little bit of typing, like a generic, and I have this code. It's 7 lines, and now I can do the thing I want to do, and it's type safe. I think that's my last slide. Ha! Descriptors. Woo! All right.
Very nice. That would mean next up is Leon Vanstone. How's that sitting? That's close enough, right?
All right, AV roulette. Let's go. Ooh. Ooh. Hooray! All right, hello. Nice to meet you all. My name's Leon Vanstone. Here to talk about green software. I know most of you are worried I'm probably a hippie. Don't worry. It's also cheap software. I've spoken to enough CTIOs and CIOs to know that's the only way they're going to do this. And a quick shout out. Thank you, Amy. Thank you, Chris, for kind of making the big point about the value of refactoring and well-maintained codes and the very real cost of tech debt. So I'm going to give you a quick introduction to green software, and if anyone wants to then come and have angry conversations with me, please do. All right, so to give you a bit of context to why we should even care about green software, global computing, according to Chow Harry et al. 22, global computing is going to use about 10% of all the power in the world, which is honestly mind-boggling. If global computing was a country, it would be the third largest consumer of power in the world. It would go China, America, and then global compute. And this study was done before ChatGPT blew everything up, right? So this could well be 20% at this point. This is also gonna result in about 5 billion tons of CO2 going into the atmosphere, about 5% from the whole world, which is about as much CO2 as contributed by all cars, fossil fuel burning cars in the world will be equivalent. You thought Bitcoin was bad. You just wait. People will be like, I don't do my computing in the cloud. I do it all at the edge. I also drive a Prius. So green software, some quick things then. So basically green software is cheap software. But the problem is you cannot change what you do not measure. If you're not actually, and there are very few tools for this. And come talk to me afterwards if you want to learn more about that. But the real truth is most code is not especially well optimized at all. New features and bug changes typically take priority. And the unfortunate truth of that is that, tech debt is obviously just annoying if you're trying to maintain a code base. But in fact, it has a very real cost and CO2 emission associated with it, like $1 cost and a grams of CO2 emission associated with that tech debt. And that is a problem in lieu of the numbers that I just showed you. And what's more, because there are no tools out there for any of you developers, most people believe that faster is better for software. And this isn't actually necessarily true. And just to give you some idea of this, we got 36 very unfortunate developers to agree to answer the same challenge. And we got 36 solutions. All of them are functionally identical. They take the same input and they produce the same output. And those numbers are very small. So the lowest number, the most power efficient version that answered this took 24 joules of power, and the worst one took 243. It's a 10x difference. Right? And it's just without any tools to measure any of this, you just have no idea. Speed is intuitive. Power consumption, not so much. We went back and we asked, we got 10. Apparently the coding challenge wasn't great fun because only 10 of them have agreed to then do it a second time. We gave them some tools to measure power. Some of them got 60% power saving. Some of them got 10. 30 is about the average. So, why I find this very motivating is globally, you're looking at about 10% power, 5% CO2 pool from something we all really believe in, I think. Computing is important. AI is important. These are tools. We should not abandon them. But the sheer cost of doing this, of using that much power, the capacity is limiting, right? If you're not optimal, if you're not optimizing, you're losing out. And obviously, I also like breathing and eating food. And those are going to be difficult as we continue to damage our environment. And there is this very real opportunity for all of us to come together and sort of push forward for the tools to save about 3% of that, 3% of the world's power, which is about the amount of power used by all of Japan. That's the opportunity that's in front of us. So if anyone wants to learn more about that, come find me. I'm sure I'll be stood around in the networking event. Thank you very much.
Last but certainly not least, Eric Adams.
What up, party people? Hi, my name is Eric. This is my quick pitch for a piece of open source software called Seat Dealer. So I've been running a local poker game every Saturday for about the last 2 years. So about 200 people have at some point come through my door. And every week that means I'm sending out a handful of invites to try to get a number of people to say yes. Once I hit that number, I really can't take any more people. There's not room at the table. There's not really room to like hang out. So I thought, I have some extra time. I want to learn Terraform and GitHub Actions and a handful of other technologies. So why not just solve this problem for myself? So I'm writing an application that will fire off SMS messages kind of every few hours in small rounds until enough people say yes, and then stop firing off those invites. If that sounds interesting to you, meet me at the stage. Bye.